I'm Pedro Ferreira, and I'm the author of The Perfect Theory, A Century of Geniuses and the Battle over General Relativity. And it's basically a biography of general relativity, and I'm going to read a bit which tells you how I first became enamored with this grand theory of Einstein's. I went to university in Lisbon, where I studied engineering in a monolithic building of stone, iron and glass, a perfect example of the fascist architecture of the Salazar regime. The setting was apt for the endless lectures where we were taught useful things, how to build computers, bridges and machines. A few of us escaped the drudgery by reading about modern physics in our spare time. We all wanted to be Albert Einstein. When it was time to study electromagnetic waves, we were introduced to Einstein's special theory of relativity. But general relativity, Einstein's grand theory of space-time, was not part of the menu. At some point, I decided to teach myself general relativity. I scoured the library at my university and found a mesmerizing collection of monographs and textbooks by some of the greatest physicists and mathematicians of the 20th century. There was Arthur Eddington, the Astronomer Royal from Cambridge, Hermann Weyl, the geometer from Göttingen, Erwin Schrödinger and Wolfgang Pauli, both fathers of quantum physics, all with their own take on how Einstein's theory should be taught. One tome looked like a big black phone book, running more than 1,000 pages, with flourishes and comments from a trio of American relativists. I felt that I'd entered a completely new universe of ideas, populated by the most fascinating characters. Understanding their ideas wasn't easy. I had to teach myself to think in a completely new way. Decoding Einstein's theory required mastering a foreign mathematical language. Little did I know that Einstein himself had done the same as he tried to figure out his own theory. Once I learnt the vocabulary and grammar, I was blown away by what I could do, and so began my lifelong love affair with general relativity. It sounds like the ultimate overstatement, but I can't resist it. The reward for harnessing Albert Einstein's general theory of relativity is nothing less than the key to understanding the history of the universe, the origin of time, and the evolution of all the stars and galaxies in the cosmos. What more could I want? So this is Einstein's equation, and it really is this. And basically it's telling you something very simple, which is if you lay down stuff in space-time, you can solve this equation to find what the geometry of space-time is, how it's warped in the presence of that stuff. That's what took him 7 years to find. There's another equation which tells you if the geometry of the universe is warped, how stuff will move in it, and it'll curve, and its paths will bend and curve as a function of that geometry. I wanted this to be a biography of general relativity. And so indeed, Einstein gave birth to general relativity, and the first 2 chapters are about Einstein creating this theory, but then it takes a life of its own, and it's all about how this theory emerges, grows, dies, then grows again, and more importantly, it's about the people who drive it forward, and the creativity and the controversies associated to it. So there's the wonderful astronomer Arthur Eddington, very brilliant astronomer, who reads Einstein's theory and decides that he's going to go out and test it. And he's really the person that puts Einstein's theory on the map with this measurement that he makes of an eclipse in 1919. There's a Belgian priest and a Soviet meteorologist who show that Einstein's theory predicts the expansion of the universe. There's a German astronomer who, while fighting on the Eastern Front, calculates the first solution to a black hole. Einstein had a funny reaction to some of the predictions to come out of his theory. The classical example is when the Soviet meteorologist and the Russian priest showed that the universe had to be evolving. Einstein's reaction to Lemaitre was that your mathematics is correct, but your physics is abominable. General relativity goes through this incredibly fallow period. You know, it's kicked into the long grass from the 1930s onward, and basically its younger sister, quantum mechanics, takes center stage, and you can do wonderful things with quantum mechanics. You can do experiments, you can build atom bombs. Late 1950s, it kind of begins again, and there are a number of reasons. One is the industrial military complex think that there might be something in general relativity that they've missed out. Maybe an anti-gravity machine, maybe some amazing propulsion mechanism. And it's from different angles, from maths, from physics, from astronomy. People start to realize that actually this theory is really good and can predict some hard stuff out in the universe. If Einstein were around today, I would say, look, it's still around. The theory is still fantastic. It's still what you made of it. I'd be intimidated about saying what he did wrong, but I think he would realize how great his theory was, and actually how all these predictions that he was wary of turned out to be really important. I loved writing the book. I was surprised how much I enjoyed it, and I think a crucial part about it was that I could indulge my obsession and I could read all this stuff, and it was a real pleasure. I'm hugely honoured to be nominated for this award. Honestly, it's completely unexpected, and I'm very chuffed, very proud that this has happened.